Hello there, welcome back. We're at the last section in Chapter 6. We are just moving right along. And here we see a very, very important application of factoring. We're going to be solving equations by factoring. But before we do that, we want to talk about what the zero product rule is. It's a very believable rule. And what it says is that if A times B is equal to 0, the only way that can happen is either A is equal to 0 or B is equal to 0. So that's a big rule. And really what it means in a case of an equation is, suppose we have x minus 3 times 2x plus 5, already factored, equals 0. What that means is either x minus 3 is equal to 0 or 2x plus 5 is equal to 0, which means either x equals 3 or x equals minus 5 halves. In other words, these two numbers, 3 and minus 5 halves, are the solutions to this equation. If x is equal to 3, this term is 0, and so 0 times anything will be 0. If x is minus 5 halves, then this is 0, and 0 times anything else will equal 0. Okay, so let's look at some examples that are a little bit more interesting than that. So what you see is that here we have an equation, and we want to solve it. And generally it's a fairly big rule of algebra that if the degree is 2, then there will be 2 solutions. There'll always be as many solutions as the degree of the polynomial. So we already know how to factor, right? So we know, or we can show, that this factors as p plus 8 times p minus 4, and that has to equal 0. So the only way that can equal 0 is if either this is 0 or this is 0. In other words, either p plus 8 is equal to 0 or p minus 4 is equal to 0. And so my solution is either p equals minus 8 or p is equal to 4. And as before, when we were solving equations, it always helps to go back and, plug it in. So I'll do this in just one case, and I'll do it for the minus 8, say. So I'm going to go back up to my original equation and put in minus 8 for p. So I have minus 8 squared plus 4 times minus 8 minus 32, and I'm asking the question, I like to do that, does this equal 0? So this is 64 minus 32 minus 32, and yes indeed, that does indeed equal 0. So minus 8 is a solution, and if I did the same thing with 4, I would see that it works also. Alright, so here's another one. Suppose we're solving this. Now, very, very important for you to notice that we don't have 0, and so we can't use the zero product rule. So we always want to get 0 on this side when we're solving these equations. So if I add 2 to both sides, I get a squared minus 6a plus 8 is equal to 0. It factors like this: a minus 4, a minus 2 is equal to 0. So therefore, a is equal to 2 or 4. 2 solutions because the degree was 2. Alright, we'll try another one. Okay, so this is the last one we'll look at. This has a couple of things that we need to be careful about. So again, we got to make sure we get 0 on one side. So I rewrite this as 9n squared plus 39n plus 36 is equal to 0. And I want to factor it, and I got to remember about the greatest common factor, which is a 3. So I have a 3 times 3n squared plus 13n plus 12 is equal to 0. Now, right here, what I can look at is, okay, I have 3 times this thing is equal to 0. The only way that can be true is if this thing is equal to 0, because 3 is never 0. So really solving this equation is really the same as solving this equation. The other way to think about that is I could have gone here and multiplied both sides by 1/3. Let me just show you what I'm talking about there. If I multiply this by 1/3 and this by 1/3, well, 1/3 times 3 is 1, so that would be just a 1, and 0 times 1/3 is 0. So any way you look at it, we can simplify this. And what we have now is a trinomial. So I go over here and I say, okay, 3 times 12 is 36. And what I need are two numbers that multiply to give me 36 and add to give me 13. And those two numbers are 4 and 9. So I'll rewrite this as 3n squared plus 4n plus 9n plus 12 is equal to 0. So out of the first two, I can take an n out. And I get 3n plus 4. Out of the next two, I can take a 3 out. And I get 3n plus 4, thank gosh. Alright, so again, please notice that common term, so I take that out. 3n plus 4 times n plus 3 is equal to 0. So therefore, either this term is 0, which means n is equal to minus 4 over 3, or this term is 0, which means n is minus 3. So those are my two solutions. And that's the solution to this original problem way up here at the top. So did a bunch of things there, and each step you should be able to follow and reproduce. Alrighty? So that's it for this chapter. That's it for chapter 6. See you when you begin chapter 7. Ciao, ciao.